very soon. Let's wait 1 minute more so that other participants that have registered going to connect so that we can enter them into the room. Okay, so I think that we can slowly start with the webinar. I see that there are more people who joined, and we will wait as more will be connecting as well. So, good afternoon, everyone. Thank you for joining our webinar, Circular Wind: Securing the Energy Transition Through Circularity. My name is Andrzej Ceglarz, and I work as a director of energy systems at Renewables Grid Initiative. And today I have an honor to host our best practice webinar with two great speakers representing Renewable Parts and SSE Renewables. But before we go into the content part of the webinar, we would like to also ask you. We would like to have some interaction with our participants, with the audience, to have it in a more let's say active way. Also to encourage you afterwards, after our presentations, to be active in the discussion. So I will move now to let's say to the first interactive part of the webinar, during which we would like to start a poll to get to know who we have in the room, who we have among the audience. So there's a pool in the perfect. I see that the answers are being completed to understand which sector the participants of this webinar are joining. I see from the answers that representatives of industry are dominating, but we also have people representing NGOs and civil society organizations, as well as consulting government representatives or academia. And second question is, which country are you connecting from? And here I can't actually see the answers. Maybe my colleague Natalia can support me.
Yes, I think the answers will only show in the end, unfortunately.
Okay, at the end. So so let's wait, because I see that people are still joining joining the webinar. But definitely among the answers, I can see that we have mostly representatives of industry, which is good, because it's going to have it will be a relevant discussion, also showing the perspectives of industrial players. So I would suggest that we move on and pool. Yeah, yes. and sharing. Unfortunately, I cannot also see the results. So maybe Natalia, if you could, are you able to see them?
Yes, so we have different people around Europe, but also Morocco, so Bulgaria, Latvia, Ireland, Scotland, UK, Germany as well, France. So generally Europe, but also Morocco.
Yeah, perfect. So it's but we have a diversified audience, which is good. So thank you for your participation. And before we start, also I would like to share a few housekeeping rules. So as mentioned at the beginning in the chat, this webinar is being recorded. It will be published afterwards on RGI website and on RGI YouTube channel. For housekeeping rules, we suggest to keep your camera on and microphone off. So there's no, on the one hand, there's no background sound that would distract the presentations. On the other hand, we could still see you and your reactions to the webinar. We also encourage you to rename yourself within the chat, so also we know who exactly and representing what kind of organization is participating and taking part in the discussion. And if you have any questions or comments, you can always raise your hand at Zoom so that you can participate in the discussion and ask the question, or you can also type the question directly in the chat. So for what are we going to do today? What we are going to discuss? That's the agenda of the today's webinar. We will start with a short introduction of Renewables Grid Initiative, RGI. Moving forward to best practices, which is going to be presented by Carol from Renewable Parts. Afterwards, we will have a short intervention from Alex representing SSE Renewables. And finally, towards the end of the webinar, after the Q&A session, we are going to conclude. So why and how did we meet here today? Maybe just to give you an overview who RGI is and why we are organizing this webinar. So RGI remains quite a unique organization within the landscape of the energy transition, as we work as an association, as a collaboration of NGOs and transmission system operators across Europe. And here you can see the geographical distribution of our members with the idea to promote fair, transparent, and sustainable grid development, which would contribute to the growth of renewables in line with the Paris Agreement. Oops. Our work is structured across three different dimensions: technical, environmental, and social one, with indication that within our work we are building synergies between these different aspects, knowing that building and implementing the infrastructure is not only a technical endeavor, but also brings environmental and social effects. So that's why we are trying to tackle them together. From the technical side, we are analyzing and we are working how to model, plan, and implement the decarbonized and optimized energy system, but also taking different voices into this discussion. From the side of our environmental dimension, we are making sure that different onshore and offshore systems are developed in coherence with nature and biodiversity, promoting different measures for mitigation and enhancement and restoration. Finally, from the side of our social dimensions, we are striving to include different voices, to include citizens, civil society into our discussions, but also on the strategies for the implementation of such decarbonized system, and also building the capacity to understand the role of the grids. So this this webinar is called Best Practice webinar, and this is part of a big chunk of work that RGI is doing. So why we are dealing with best practices? Because we believe that sharing knowledge and the transfer of knowledge can cross-fertilize different solutions between industrial actors, between NGOs, between all those who are involved in the energy transition. So what we do, we collect different practices. We publish some reports or brochures about them. We also have our online database, which includes these different practices. We talk about those during either webinars like this one today, but also during conferences, workshops, or other high-level events that every year lead to RGI Grid Awards, being awarded in 3 different categories, similar to the dimensions that RGI is dealing with. So the technical one, environmental, and related to communication and stakeholder engagement. Within our technical work, within the technical dimension, as mentioned, we are trying to analyze and also promote how to build a carbon-free and optimized energy system. We have different work streams dedicated to this work, and one of them is dealing with climate change adaptation, and bringing on board also topics of resilience and circularity. And why is it so? So if we are talking about optimized energy system, this optimization can come at many different levels. It's also about use of the resources that we need and that we will need to implement the system, and how to make the best use of those, how to use it in efficient way. And this is important also to think about it from the system perspective, from the optimization at the system level, because it's not grids play important role, but it's about different technologies that will compose this system. And in this specific context, wind plays a very important role, knowing that the pledge for tripling renewables has been accepted last year at COP, knowing that by 2030, at least 42.5% of renewables shall be in the European Union's energy consumption. And by 2050, so by the middle of the century, wind energy is expected to provide up to 58% of overall electricity consumption in the European Union. And building so much wind power, building so much infrastructure will require huge investments, whereas those investments and implementation are facing the different challenges related to scarce resources, related to disrupted supply chains, what was very much visible during the COVID-19 pandemic, as well after Russia's attack on Ukraine. Also, global competition leads to increasing costs. Whereas the measures related and measures and approaches related to circularity can address these challenges. They can reduce environmental pressure, increase security of supply, provide different social benefits. And this has been recognized also by policymakers, especially last year, let's say on the science side, on research side, with some of the reports being published by the Joint Research Center, but accompanied also by publishing of the Net Zero Industrial Act or Critical Raw Materials Act by the European Union. So being aware on the one hand, on the need to implement the system with a huge need for resources, what is being accompanied by on the policy side, we find this topic very relevant to discuss about. Last point that I wanted to mention about giving some background about this specific webinar is about one of the projects that RGI is implementing. The project is called Just Wind for All, and it's a Horizon Europe research project that aims at supporting the acceleration of wind energy through just and effective governance. With this project, we try to combine different scientific methods of impact assessment, of techno-economic modeling, and dealing with social, environmental, technical, and economic impacts that should be embedded into the decision making. Also, within this project, we have something that it's called Wind Forum, where we try to bring different actors, where we try to bring different experts from the field to enable knowledge transfer, knowledge exchange on the topics that could actually feed into the objectives that we are trying to achieve with this project. And I think that I'm going to finish now, and I have a pleasure to introduce our first speaker, Carol Schitt, who is Engineering Program Manager in Renewable Parts, also being an active member of the Wind Fellows, so our let's say advisory board of Just Wind for All, who is going to present best practice related to circularity in the wind industry on the example of renewable parts. So I'm going to finish here and stop sharing my screen. And Carol, the floor is yours.
Thank you. Okay, thank you very much, and thank you for the invitation to speak to you today. My name is Carol Schitt. I'm Engineering Program Manager at Renewable Parts. I'm going to give you an introduction into our company, who we are, first of all, and then we'll talk to you a little bit more about what we do and how we're creating a circular economy for the wind industry. Our company was formed about 12 years ago by a man called Ewan Anderson, who was working as a technician in the wind industry. He was going out to wind farms regularly and regularly seeing the image that you see on the left there. So skips full of used parts from wind turbines that had simply been removed when they either failed or came to the end of their life. And were being replaced by new. That was the default, that linear procurement practice of use it, and when it comes to its end of its life, throw it away and buy a new one, was the common practice and the default practice. And Ewan's idea was simply to change that, which was to take the parts that were coming out of these turbines and do something with them. Ideally, put them back into turbines as reusable parts. And that, yes.
Sorry to interrupt you, but we cannot see your slides.
I cannot see the slides. Can you see now?
No.
No.
What's going on? Now?
No, unfortunately, we cannot
So-
see your slides.
I can present for you and then I'll pass
Yeah.
the slides for you if that's okay.
Yeah, that's fine.
Yeah. Okay. Just a second. Can you all see it?
Yes.
So slide 3, yeah. So this will make more sense now. So this was the image on the left that prompted the basis for the company being formed. If you move to the next slide, please. So today our company provides two main services really. So we supply parts, both new and refurbished parts to the wind industry, and provide inventory management. And the other part of our business is focused on the development and production of the what we call recirculated products, which basically means that they could be refurbished, remanufactured, or incorporate reuse. But however we get there, we're reusing parts from the wind industry and putting them back out into circulation. We do this across a range of wind turbines, makes, models, and we work with a range of customers from turbine operators to the turbine manufacturers to farms who have 2 or 3 wind turbines in local communities. And through this work, we're enabling significant carbon reduction in the supply chain of the wind industry. Next slide. We are based in Scotland, so our main operations and logistics hub and warehouse is in Renfrew, which is just outside Glasgow in Scotland, and our refurbishment and innovation centre is in a small town called Lochgilphead on the west of Scotland, about 100 miles from Glasgow. So those are our two main sites. We provide supply chain operations all across Europe and wider than Europe now as well, across the world, supplying parts globally now. We have local representation in Spain. Our business development manager there is responsible for our operations outside of the UK and sales outside of the UK. And we have recently launched Renewable Parts LLC, which is our operations in America, based in Texas in the US, where we're aiming to replicate what we do here in Scotland in America. Next slide, please. So that's a brief introduction to the company. I'm now going to go into a little bit more detail on what we actually do when it comes to recirculation of parts and how we're achieving that circular economy. Next slide. So what do we mean by circular economy? Hopefully a lot of you are familiar with this diagram or one like it. But essentially, to achieve a circular economy, we're aiming to design out waste and keep products and materials in use for as long as possible. So we're trying to keep that circle as small as possible. When it comes to a wind turbine, the best thing that you can do there is to service the wind turbines. So if a part fails in service, you service it at site. And keep it in service for as long as possible. That's not something that we do, so we're not climbing towers and servicing turbines at site. All the material we do with our parts that have come out of turbines. So we're really focused on those middle aspects of the circular economy diagram, where we talk about remanufacture and parts harvesting. We recycle anything that can't be reused, but our primary intent is to reuse it if we can. Next slide, please. So the processes in the middle there's quite a range. So we talk about remanufacture, we talk about refurbishment and repair. And essentially, these are all different value retention processes. The aim of those processes is always to retain as much of the original value of the part from its original manufacture as possible. but there are variations in all of them. They do vary in terms of what's required and what they achieve in terms of the part that you get at the end. So they vary from remanufacturing, where your intention there is really to create a part which has the same expected life, the same service life as the original part, the new part that was made in the first place. And then you move down the chain through comprehensive refurbishment, reuse and repair, and you can see the variation from this useful chart, where you're seeing variation in life, and along with that you get variation in the cost to actually achieve the process and provide a finished part. You'll see variation in the warranty that's offered, and obviously the variation in their service life. What we are aiming to achieve with what we are doing is as close to remanufacturing as possible. So either remanufacturing or comprehensive refurbishment, but we aim that all the parts, the recirculated parts that we put out, have a warranty equivalent to new, and therefore fulfill one of those top two value retention processes. Sometimes it's not possible, maybe due to unavailability of parts, but we'd be clear where that was the case. The other one that's not mentioned on this chart here is redesign. So we see a lot of parts coming out of wind turbines, and through that we were able to look at the failures and the wear of parts, and identify where actually improvements could be made. So improvements that maybe haven't been made by the original part manufacturer, that we could incorporate as part of that recirculation process, again in helping to reduce failures and extend the life of parts. Next slide, please. So when we get a part in to look at for the first time, this is really the process that we go through. So we would disassemble that, as many as possible, ideally to gather as much information as we can about the condition of the parts and the failure modes. And then we'd go through that middle block of questions there and work out which components are suitable for reuse. Where can we either repair or refurbish individual component parts? Are there any component parts where we should be looking at redesign or modification to help design out failure modes? Or are there any component parts which are just unsuitable for reuse when we're trying to achieve a part that's as close to new as possible? So a good example of that might be seals and bearings, for example, where really you want to be replacing those with new to make sure that you're getting an as new service life again. So once we've determined that, those parts would go back into the reassembly of the assembled part, along with any new parts that we've identified. If new parts aren't available, then we would look at processes like reverse engineering to get an equivalent part. And then potentially combining reverse engineering and manufacture with redesign as well. So the parts that we produce can follow a number of different processes to get to a finished product. But like I said, we're always trying to aim for that part that's equivalent to new and can go back out and do an equivalent life and service again. The process we go through, it can be reasonably straightforward and take us a matter of weeks in terms of developing these parts, or it can be significantly more complex than that. An example of a part that we've looked at is a yaw gear for the Siemens 2.3 turbine. If you move to the next slide. So this was a project that started back in 2018 and is still ongoing, to be honest. We're always learning something new and looking at how to improve our products. So this yaw gear, and there are 8 of these on a 2.3 CS wind turbine, used to turn the nacelle into the wind direction. And these have a common failure mode. The stage 4 planetary carrier fails quite often, and so we started a project back in 2018, looking into the failures and looking into how can we refurbish these parts. in order to ensure that the wind industry has a supply chain for them. So one of the main issues they were having was, because they were failing, there were long waits and high costs for the replacement parts. So that's really where having that circular economy provides a benefit to the wind industry. I won't go through all the detail on the left, but it gives you a bit of an idea of all the steps that we've been through with this project. We've been fortunate to benefit from a number of funded projects. We've worked closely with different departments in the University of Strathclyde, including the Advanced Materials Research Laboratory. And we've also worked really closely with one of our customers, SSE Renewables, which is really important when we're trying to develop any refurbished product, is to get that knowledge and information from the technicians and the people at site who are dealing with these products on a regular basis. So it's really been quite a collaborative effort between all these parties over the past 5 years. Or more now. And what we've managed to achieve by that is firstly having a refurbished product that we can offer, so that ensures availability of parts for the industry at a reduced cost from new. We've developed a UK supply chain for the stage 4 planetary carrier. So we've developed a like-for-like replacement part there, because the supply chain for that was really unstable, and that was causing blips in lead times and costs. And that's gone through extensive testing to demonstrate that we can provide a like-for-like replacement there, so including metallurgy testing, static load testing, fatigue testing, to ensure that we've got an equivalent product there. We've introduced what we refer to as a dampening kit, which is a modification to the gear, which is looking to try and dampen out the load that these gears are seeing in an effort to try and reduce the in-service failures. And we've made the gear into what we call a quick fit assembly, which means it comes filled with oil and ready to go, which is an efficiency saving at site as well. And on top of that, because we've seen so many of these gears, we're always gathering data for our customers as well. So looking at variations in failure rates across sites, for example, feeding data back into looking at the what's causing the failure of these gears. So is it the gear itself, or is it actually a wider system issue on the wind turbine? And a lot of our customers don't have the time and the resource to be stripping these gears and trying to work out what the problems are. So the data we're gathering is really important to feed into those investigations. This is an example of probably the most extensive technical project we're doing. Like I said, some projects can be a lot more simpler than that, but yeah, it really varies depending on what we see from the parts that are coming in and what's causing them to fail. Next slide, please. So as well as the efforts, the technical efforts to determine the best work scope for refurbishment, there's a couple of other things that really enable the circular model to work really. So one of those things is we make return of a used part a condition of supply. So we aim to have refurbished parts on the shelf ready for our customers to buy. And if they buy one of those, a condition of sale is that they return their used part back to us. And that's really fundamental to completing the circular loop and ensuring we've got stock of material to keep that loop going. One of the key enablers for that is reverse logistics. So when we first started trying to implement this business model, one of the real sticking points was we were starting to manage to sell parts, but those defective parts weren't coming back to us. So for most of the parts we've developed specific packaging for those parts to make it as easy as possible. So when you take the refurbished part and put it into the wind turbine, it's really easy to take the defective one and pop it back in that packaging for us to collect or to be shipped back to us. It sounds really simple, but ultimately, if it's easier to throw it in a skip, quite often that was what was happening. So we tried to make it as easy as possible to get that material back to us, so that we can keep the loop going. I've shown pictures of parts in a number of these slides. I think I've used the yaw gear there that you can see in this loop as an example going through our refurbishment loop there on the screen. If you move to the next slide, just give you an example of the range of parts that we're looking at. So I think we're quite unique in what we do, in the sense that our focus is on delivering solutions to the wind industry rather than on a specific part type. So a number of the parts we refurbish, we do in-house, but we also work with a number of other suppliers as well to bring these solutions to the wind industry. And in that case, we would oversee the work scope and what they're doing, and make sure it comes up to the standards that we're setting for ourselves in the refurbishment that we do. So we look at parts across the wind turbine. We refer to most of these parts as minor parts. So what that means is in terms of value in the overall scale of a wind turbine, they're less expensive than some other parts, which is probably why the default option was to just throw them away and buy new. But obviously there's a lot of material in these parts, and a lot of value as well. So but these are the parts that we focus on. But you'll see it's across mechanical, electrical, hydraulic parts, you know, anything where we can look at reuse and recirculation of parts. We'll do there. The three pictures you've got there, there's an oil pump and motor on the left side, you've got the yaw gear in the middle, and the one on the right is a Siemens 3.6 yaw brake caliper. So there's 8 of these on every Siemens 3.6 turbine, and there's thousands of these turbines out there, and they require replacing regularly because they have brake pads and seals which wear over time. So you know, you can imagine the scale if all those were being thrown away and replaced with new every time. Next slide, please. And just a couple of slides to wrap up then, and on why we're doing this really, and what the benefits are, I guess, to us, to our customers, and to the industry. Sustainability, obviously, the more parts that we can reuse, the more value retention we do, the greener our supply chain, essentially. So that yaw gear that you saw there, the number of parts that we're reusing in there means that that's approximately 400 kilogram CO2 equivalent saving every time we refurbish one of those instead of buying new. So it really stacks up when you think about the number of parts in a wind turbine. Quality, as I said, our aim is to be able to offer a warranty equivalent to new, and avoid repair wherever possible. So it's proactive replacement of components that are subject to wear to ensure the quality there. Availability, generally we aim to hold stock of high consumption parts, and even if we don't hold stock, we can generally refurbish and replace quicker than the availability of new a lot of the time. So if you translate that into avoidance of turbine downtime and availability of wind turbines, it really has a positive effect as well. Cost, in most cases, there is a cost saving relative to new. And we can ensure more stable costs than new parts as well, based on the business model that we create. Data, I've mentioned as well. So all the parts that we provide are serialized, so we can track them through out into customers. We can look at whether they come back to us, how long they're performing in service. We can provide data to customers on whether there's a site that we're seeing more parts come back from another. So there's a lot of useful data from these parts and failure modes, that if the parts are being thrown away, that data is being lost and not being acted on in terms of improvement. And then lastly, the social and economic benefits. So particularly where we are in the UK, we're creating a circular supply chain, which means we're keeping the material in the UK and we're creating jobs from that material as well. So keeping everything more local, creating new jobs, and obviously then the social benefits that new jobs in areas local to wind farms that brings as well. And from the next slide, so that as well as there being benefits, there are obviously challenges as well. The one at the top of the list is perception. So we still find there is a lot of negative perception around the use of remanufactured and refurbished parts. And that does limit uptake, particularly where the cost saving relative to new is lower, which brings me on to the next point, which is economics. So where we're aiming to have a comprehensive remanufacture or refurbished solution and offer a warranty equivalent to new, that's not always cheap. I mean, it's not always half the cost of new, which we find is sometimes what customers expect. So we're always trying to strike that balance between a quality product and providing a cost saving over new, and where we can't achieve that, sometimes customers default to cheaper repair options, which then feeds that negative perception all over again, and we go around that loop again and again. Data, there's a lot of data out there that would really allow us and other people doing what we're doing to scale up more quickly. And there's good reasons why a lot of that data isn't available, but things like failure rates, bills of material, parts lists, the design requirements, which are obviously the OEM, the turbine manufacturers information. If all that was more available and there was more collaboration on that, we could really scale this up much quicker, develop refurbishment solutions much quicker and more cheaply as well when it comes to research and development time and effort as well. Component part availability, again, either due to obsolescence or protection by manufacturers. Often when we go to find a replacement part, it's not available, and then we're into, okay, can we reverse engineer that? Can we find an alternative? Reverse engineering is in itself is to be expensive, but the testing procedure to demonstrate equivalence can be quite expensive. So then you really need high volume to make it work, and we don't always have that in every case. And then lastly, the process. So, many minor parts continue to be scrapped at site because we haven't got the processes in place to deal with that material, or it's actively restricted, or procurement processes don't allow repair or refurbished or remanufactured to be compared with new in the best way here. So there's a number of challenges still out there, but all this is changing. It is moving in the right direction, but there's still a lot we can do to make it move faster. And so on my last slide, just a quick word about QUIC, which is an industry programme launched by ourselves alongside SSE Renewables and the National Manufacturing Institute of Scotland as part of the University of Strathclyde. And that programme was launched jointly between those parties exactly to deal with some of those challenges that I've just mentioned, but to really look at the scale up of the circular supply chain for the wind industry and deliver sector-wide solutions to those challenges. QUIC now has over 45 members, ranging from turbine operators through to universities, academia, and industry peers. And it's aiming to deliver that by developing remanufactured solutions, establishing more collaborative partnerships in the industry, sharing of data and more working together, working with government to influence policy, and developing the people and skills that we need to deliver that. So QUIC is currently going through a governance structure change this summer, and hopefully at the back of that you'll hear some more about the plans that they have for the future and to help address those challenges, we hope. Thank you very much.
Thank you very much, Carol, for this great presentation. And before we move to the Q&A session, I would like to invite our second speaker for a short intervention, Alexander Highworth, working for SSE Renewables, the company that Carol just mentioned about, to make a short intervention about, let's say, two other aspects that were touched upon in input presented by Carol, and maybe to develop or elaborate more on that. The first one would be about the, let's say, regulatory aspects, about the policies. What is needed still? What is there? What is needed, and what is the desired for the European wind industry to incorporate and further develop circularity practices? And the second one, looking from a company, from a kind of corporate perspectives, what are the options, what are the possibilities to internally develop the strategies to implement circularity approaches? And yes, and I will stop here. And Alex, the floor is yours.
Thank you. Well, first of all, I want to thank everyone from RGI for inviting me to speak today, and also extend my thanks to Carol for that brilliant presentation. If anyone finds themselves in Loch Gilphead, I'd really encourage you to try and get along to a visit at the RPL site. I've been twice, and it really is fantastic to see all of the practices that they have. It really is circular economy in action, and yeah, both times I'm just overjoyed. I'm not from a technical background, but to see all of that work going on firsthand is just brilliant and really, really encouraging. So yeah, I would recommend getting along if that's possible. So I work for SSE Renewables, a big renewable energy company, primarily operating in the UK and Ireland, but we've also got a number of onshore assets across Europe. I think Poland, France, Greece, and Spain, I think, are the predominant countries at the moment. We're also looking to expand into the Asia Pacific market in Japan as well. In terms of policy recommendations around circular economy, I think it would be impossible to come on a call like this today and not call out the Dutch seabed auction, the results of which were concluded last week. So if you're not aware, the Dutch were auctioning off two 2-gigawatt offshore wind sites called Emuidenver Alpha and Beta. Both of these sites had pretty extensive qualitative bid criteria, which means that it wasn't just around the amount of money that the bidders were going to pay, but also other factors which were important to the development of the offshore wind farm. So Site Alpha, for example, had a really big focus on ecology, and Site Beta really focused on systems integration, but both sites actually awarded 10% for circularity. So I was fortunate enough to manage that work stream on behalf of SSE Renewables and our JV partners at APG and ABP. And through this auction, yeah, 10% of that criteria is around circularity. So that really enabled us as a business to engage really coherently with ourselves and with our design teams and engineering. Never before have I pushed on such an open door when it comes to having those conversations with engineers right at the design phase of the project. And at that point, you know, everything's on the table, no assumptions have been made, and there really is an opportunity to challenge that. So while I can't at the moment comment on the innovations and interventions that we put into our bid, I would say looking at ways and systems to reward businesses which have developed circular economy innovations or strategies or new products within the supply chain, that is a really, really important way to drive that culture into the business. And as I say, resulted in a lot of really, really positive, interesting and constructive conversations, both internally and then with the supply chain. Moving on, one of the other recommendations that we would look to see developed would be a standardization of reporting framework. So for circularity, it's really challenging to find a transparent way of measuring the success of circular interventions. So in her presentation, Carol talked about measuring the carbon saved as a result of not landfilling one component or a series of components. And that has sort of been used as a bit of a stand-in for measuring circularity in the past, and it can be helpful, and I do find it's a useful way to start having those conversations. But it can also be a little bit of a blunt instrument because I would use the example of critical raw materials, right? We know that in order to build out the supply chain and build out the scale of renewables that we need, our current approach to critical raw materials is not sustainable. But the embodied carbon associated with those components, particularly because the quantities are so small, means that you could very easily, if you just took a carbon-focused approach, focus all your intention on recycling steel or aluminium or copper, and that would result in a really positive circular innovation. But that's not going to be sufficient if we want to build that in the way that we do. So really, we need to find metrics, we need to find systems that can recognize circularity in all forms, not just using carbon as a sort of proxy metric. At SSE, we are keeping a close eye on the draft European sustainability reporting standards, particularly around, there's one on resource use and circular economy, which is at the moment in draft phase, but it's got a number of recommendations there. I'd really like to see where that's going. We also sponsor an NGD researcher called Eve Andrews, who's developing a set of metrics which will enable, at the project level, teams to assess the circularity value of different design choices and circular innovations. So if anyone's interested in that particular piece of work, I can put you in touch with Eve after the session. So either put a note in the chat or contact me via LinkedIn. And I think those are probably the two biggest policy recommendations that I would have. And then the sort of tertiary one would be, I don't know, maybe this is anecdotal, but I find that my LinkedIn feed is absolutely filled with updates from various suppliers or initiatives or academic bodies highlighting their latest circular innovations and, you know, really championing circular economy. And it's really great to see that there is an audience for that and there is an appetite. But I would be slightly cautious because often these innovations are very positive, but they don't necessarily then translate into commercial scale services or products. And I definitely call out Renewable Parts as an exception to that. They have managed to turn their service into a model that is commercial scale, and there are other businesses that are doing that. But when we see innovations around blade recycling or other components or alternative raw materials, I struggle then to see how those projects translate into real commercial offerings that we as a business could then go and procure or embed into our practices. So I would like to see more financial incentives at European level to sort of enable those interventions and innovations and allow them to proliferate into real tangible changes within the supply chain. So the second part of the question that I was asked was around the internal interventions and the internal challenges that businesses like SSE might struggle with in order to sort of transition to this circular economy. And I think a lot of the above are true. The non-price factor piece, for example, that really having non-price factors in this instance enabled lots of really good conversations internally. Similarly, that affects economics, and then that helps create a bit of a perception in the business. So I think that one is a really key piece to driving internal behavior change, because if you can look to the market and you can see that this is what the market is demanding, then that can be a really powerful tool to use when engaging in those conversations. I think Carol, in one of her challenges, touched on data, and I'm going to come back to that because metrics are also really important, not just internally, but also when supported by real supplier transparency. So we at SSE recognize that there's still a nascency of data around waste reporting and outputs and assessing these inputs. And currently the status quo is that that can lead to uninformed decision making. So really what we need in order to enable positive informed decision making is really clear metrics in terms of waste, diversion, substitution of raw materials, and then partnered with supply chain transparency around those elements. So one of the ways we're tackling this is we've partnered with Action Sustainability, who are the consultancy arm of the Supply Chain Sustainability School, to develop something called the Supply Chain Data Capture Tool. I'm not responsible for the name. I definitely think it should be catchier than that. But this metric basically allows us to allows all of our suppliers to upload their data at project level at regular intervals, either a monthly or 6 monthly basis, which enables us to then have really informed, active conversations around where that waste is coming from and embed that learning into future projects. So that tool is now live across a number of SSE solar projects, and it's going to go live on our next onshore wind project to be developed, which will be Aberada Wind Farm. The last 2 points, and again, I think these are a little bit diminutive relative to the first two, would be around the storytelling of successful initiatives. So one of the things that we have got at SSE is a really good relationship with our IT supplier. They've got a really transparent approach to recycling and refurbishing end-of-life equipment. IT is something that almost everyone in our business has exposure to and can recognize when it works and when it doesn't work. So finding that common ground to use that as a case study to communicate the value of circular economy can really be pervasive in people's consciousnesses. And then lastly, I would definitely echo Carol's recognition of Quick as the point around having a collaborative mindset, not just with your suppliers and not just with academia, but also with your peers and competitors. And I think that's what SSE is trying to achieve by engaging in Quick, as well as some of the other industry bodies that we're in touch with.
Great, thank you very much, Alex, for your information and for mentioning about so many points. I think it's very relevant and a very nice complementary to what Carol presented, also showing the different perspectives. And with saying that, I would like to move to the last part of our webinar, when we will give also possibility to our participants to speak up and also ask the questions. So as mentioned at the beginning, please either raise your hand or put a question into the chat. There was one question, but in the meantime, the answer has been delivered by Carol. So yes, please take actively part in the discussion. You can also comment, not only ask the question, and to address them to both of our speakers. And yes, as for now, I don't see any hand raised or any question in the chat. And if that...
I can, do you want me to? I think I partially answered the question in the chat, but I can answer the other part while you wait for more questions to come in if you want.
Yes, please go ahead. But I also see that Andrea just put her camera on, so maybe also Andrea, you would like to elaborate on the question.
Oh, maybe. Hi, thank you, everyone. Thank you for this super interesting presentation. I'm Andrea Weiner. I work for Front21. We are a global network of actors of renewable energy. And building on the idea of non-price criteria, I wanted to ask something else, which is about sometimes the balance to find between how to say, efficiency and circularity, or efficiency and sustainability. For instance, in offshore wind turbines, where we increasingly are using the technologies that use magnets, permanent magnets, as opposed of the technologies that use not permanent magnets, basically, but because the argument uses that these technologies require less maintenance. But on the other hand, if we go for a circular economy, we would value maintenance over extracting more materials. And I wanted to know what kind of thinking you have on these questions.
Great,
I'm
thanks.
not sure my question is clear.
Yes, Carol, would you like to start?
Yeah, sure. I mean, I think that there's obviously a key consideration that should be made in the design stage of the of wind turbines. So when you're looking at the kind of life cycle, I guess the life cycle analysis and the raw materials required to keep a part in service for as long as possible to maximize that value retention. So I think it is more a question that the turbine OEMs really should be wrestling with. But I think from our point of view, the turbines that we're dealing with are turbines that have already been are already in service and have been for a long time, and therefore the material is already there, and the best thing we can do for value retention is to keep those parts in service in their current state for as long as possible, and so that's that's what we're working towards. But yes, I would certainly like to see more of that consideration put in the design phase. So not only around the choice of materials, but that design for circularity argument as well, in terms of can you actually take the thing, disassemble the part and replace the parts that you want. So quite often we do come across parts that are sealed units, and effectively by trying to get into the parts you want to replace, you have to replace the whole a whole module, or and then it becomes non-economical. So I certainly think there's a lot more to be considered in the design aspects of these parts. And a lot of that, I talk about the turbine OEMs, the turbine manufacturers, but actually a lot of the turbine manufacturers are assembling a turbine from parts that are manufactured by other companies. So there's an additional element of the supply chain there that needs to be thought about and joined up. Really, are the people that are manufacturing those smaller parts, are they joined up to the thinking about how somebody is going to maintain this in service, and what's going to be done with it? And I think a lot of those elements are still quite detached when trying to think of that start to finish life cycle of a product.
If I can come in as well, potentially.
Please,
I think I've got a sort of a two-part answer to the question from Andrea, and I think it's a really good question to be asking, and it hits upon a lot of the complexity that we struggle with is what's the most unsustainable thing, right? That's something that I try and think about a lot in my job, and I have to recognize that sometimes the most unsustainable thing is the wind farm doesn't get built, and in the hierarchy of that, and then is the wind farm fully circular, or is the wind farm carbon efficient, or have human rights issues been created as a result of this? So it's a real challenge, because as sustainability professionals, we're very multidisciplinary and constantly grappling with those questions. And I think because of the way the industry is focused at the moment, there is this drive through seabed auctions or contracts for difference or other mechanisms, which means there is this permanent race to have the bigger, better, larger, higher capacity turbine. And I think that creates an environment where things like circularity aren't always prioritized, or aren't even on the agenda. And there is a real nuance to that. One slight caveat that I will say is that with the direct drive turbines, my understanding is that we are able to extend life even further. So, a lot of the gearbox turbines typically had a life expectancy of 20 years. We're now seeing that they can go to 25 or beyond. But some of the direct drive turbines that I'm looking at, it's kind of going from 30 to 35 years. So I can't fully get into the nuance of all of those materials and everything that's been embodied in that process. But when I'm pondering questions like this, it does help me to think about the overall lifespan of that at an asset level. and then afterwards get into some of the component level conversations. So hopefully that provides a little bit of clarity from my perspective, but I echo Carol's thoughts on wishing that some of these conversations were higher up the OEM's agenda. But I also recognize they're very stretched and they've got a lot of external and internal challenges that they're seeking to overcome.
Great, thank you, Alex, also for this complimentary answer. And I see that among our participants, there's Christian who raised his hand. So Christian, the floor is yours.
Yeah, thank you very much. Yeah, my name is Christian Patrick. I work for Airborne Wind Europe. So that's the airborne wind energy industry where we take circularity also very serious, especially by reducing the amount of material that goes into these systems. But my question is rather directly related to what Alex just mentioned, the extended lifetime. Which I really find an interesting thing, which I just heard at the IEA Wind Exco meeting. There's a task 42, lifetime extension of wind turbines. And Asker, who presented that, he said that we should rather think using wind turbines not for 20, 25 years, but really thinking of building wind turbines that last 50 years. Because if you think about other infrastructure that requires a lot of steel and concrete, like bridges or highways or whatever, you don't build them for 20 years and then you take them all off again and build them again. And a lot of that stuff which goes into a wind turbine is concrete and steel. So I wanted to ask how you see that. You already mentioned 30, 35 years, but how do you see it getting to 50 years? And we discussed that there at the dinner, and he said, well, there's a lot of issues with the financing then, and you have to think about it differently. But I indeed think it's something that should be tabled quicker, because every turbine that is being built now, if you have to take it off by 2050 again, then we have an issue there if you have to repower all of these. The other thing that he mentioned, you said turbines run already until 25 years. He said that they see that they run even 29 years in average. And then they are not even going back to somehow into recycling, but they are shipped to some other countries and they still continue to run. So that's also something to be considered, that the current turbines actually last quite a lot longer, which makes it difficult to set up the recycling processes. So I just want to hear your thoughts on these things, Carol and Alex. Thanks.
Many thanks, Christian. Yes, go ahead.
Jump in. Yeah. So I think on your first point, around designing projects for 50 years, I think so much of that is reliant on the policy environment that you're operating within. So we in SSE, we're starting to look at repowering for a number of our sites, both in the UK and Ireland. And in some instances, the initial consent or the land rights are a real barrier to that. And we're then finding that there's potentially opposition from local people in the vicinity of those assets who almost feel like, okay, we've done our bit, we've had this wind farm for 25 years, now it's someone else's turn. And I think that attitude hopefully isn't particularly pervasive, but that's definitely what we picked up from some of our sites, which can be frustrating. But also in terms of the financial perspective from the policy environment as well, if we're looking to secure a contract for different or some sort of market mechanism to support the investment that we're going through, those mechanisms currently squeeze our projects very, very tightly in order to produce the maximum amount of power for the lowest possible cost. And that means that decisions which we could make to provide, for example, a bigger offshore a bigger offshore platform, a wider concrete foundation, or more robust systems, it means that we're not able to make those choices because we're already on this sort of race to the bottom in terms of price. And, that's a point that I think is a conversation that we would like to see unpicked a little bit further. So I think those would probably be the biggest reasons from my perspective right now as to why that hasn't quite been happening. But of course, as you identified, there are evidence of turbines lasting for huge lifespans, and I think that untapped resource and that untapped potential needs to be something that we consider. But it's only possible if we get real support from the OEMs in order to prevent components from becoming obsolete, and having a transparency when it comes to the maintenance and repair of those components. Because if you end up installing those assets in another place and that supply breaks down, then you're going to end up with stranded assets, and that then doesn't breed confidence in the sort of extended life period.
Yeah, thanks very much. Interesting.
Carol, would you like to complement?
Yeah, I mean, I think Alex has answered the question well around the different reasons why you would or wouldn't extend the life beyond 25 years. I can't add too much more to that, but you know, obviously we have an eye on the older assets that are coming up to that age, and ensuring that you know, we're looking at the supply chain and ensuring that we're creating refurbishment solutions for parts that are at risk from obsolescence. And so any sites where you get life extension, we can try and support those as much as possible through circular solutions, where the new parts aren't available. And we're also looking at you know, what happens if they're not extended, so the decommissioning side of that, which you know, in Scotland is going to be significant. You know, in the next few years, that's really going to start in earnest. And yeah, I'm glad you mentioned about these assets potentially going to other countries and being ran on there, and I think that is a very real scenario. So again, processing those assets properly when they do come down is really key. And you know, I know SSE Renewables and other operators are now looking at that as part of their you know, their bid processing for decommissioning is looking for that circular aspect and that material processing aspect. So even if they do come down, there is a lot that we can do in terms of the processing of that material, making sure that's being done properly, so that we can you know, continue to retain as much value as possible from those assets, and continue to support any assets that can be re-erected and run on elsewhere.
Thanks.
Thanks a lot. And I saw there's another question in the chat, also from Andrea. It's about component standardization, whether this is something that you work at. Because you mentioned, I think, Alex, also about the standardization when it comes to reporting frameworks, but what about like the component standardization?
So again, that's something that we would very much look to be driven by the OEMs, the suppliers of our assets. I think there is a recognition that would be really beneficial and provide a lot of clarity and support around mitigating that risk of obsolescence, but also allowing components to be repaired and then reused across multiple turbine platforms. And that would actually enable old components to go into brand new turbines, which is an innovation that I'd really like to see at some point in the future, because as Renewable Parts have demonstrated, you can do that without any loss of warranty as a result, or risk created as a result of that. But it's not necessarily something that we as a developer and as an owner and operator have a huge amount of influence over at this stage.
Okay, thank you. And Carol, would you like to complement?
Yeah, I just agree with Alex. Definitely something that we would like to see as well, and the lack of standardization, I think makes what we do more difficult on a daily basis, basically. And you know, we're not just talking about lack of standardization across different turbine manufacturer types. It's across different models, and it's within models as well. So you know, sometimes somebody will say, oh, can you do the yaw gear from this turbine? And we'll say, oh yes, we've done a few of those before. And then they send it to us, and actually it's a different model because there's been some kind of minor design change. So so the lack of standardization today is a huge problem. So yes, unfortunately, not something that we have control over, but yeah, definitely another opportunity, I think, for the industry.
Thanks a lot. And there's another question from the audience in the chat. At which level do you think circularity must be addressed as a non-price criteria in the new auctions? And the question was asked by Paula. So Paula, if you are there, maybe you would like to elaborate.
Hi, hello. Can you hear me?
Yes, we
Yes.
can hear you.
Yeah. Yes, my question is more related at which level. I mean, because to make a compromise today, you have to take in mind the in long term which will be the scenario for circularity strategies. So what do you think we need to consider for the new actions, like investments in new strategies, or to make a more specific compromise?
Thanks. Yes, Alex?
So it's tricky to, I guess it's more a question of in what way do we implement circularity within non-price factors. Obviously, during my presentation or my intervention, sorry, I referenced the Amuiden seabed auction, and the bid criteria is entirely public, so potentially you could spend some time looking at that. But in summary, that criteria is around the quantity of circular innovation. So in order to score points, you needed to demonstrate that across each of those packages, you had a circular solution, you had 4 circular solutions for refurbish, 4 for substitution of raw materials, 4 for recycle, etc. So that was how you picked up points in that mechanism. But that didn't necessarily assess the value of those circular initiatives. And it's very easy to picture a scenario where you instigate something broad brush like turbine, increase recycled content in your wind turbine, right? And if you set a threshold or you set a race to do that, you might end up in a situation where developers are doing unsustainable things in order to secure that recycled content. For example, they could be shipping in steel from all over the world in order to recycle that steel to then put it in your wind turbine. So it definitely can't be circularity at any cost. So I guess to provide a little bit of direction, I would like to see an environment where circularity is consistently considered as one of the criteria in new auctions, but I definitely wouldn't envision a solution where that is the only way which decisions are made.
Thanks a lot. And Carol, would you like to compliment?
Yeah, I don't think I have too much to add on that. I think Alex has covered that quite well.
Okay, perfect. Thanks a lot. And there's another question in the chat just appeared. So Anse is wondering what are the different types of ways to monetize circularity or the different types of business cases. So Anke, sorry, I don't know what is the proper pronunciation. Maybe you would like to elaborate on that?
Yeah, sure. Sorry, maybe the question wasn't clear. Sorry, can you hear me?
Yes, we can hear you. Please go
Yeah,
ahead.
perfect. I was just wondering in terms of the different types of business cases and who in the end is sort of paying for the services and how that gets monetized. Are there obviously there is an extra cost with all the maintenance, and I wonder if there are different kind of scenarios that you have encountered where different parties pay, or it's collaboration of paying for the maintenance. And yeah, I'm interested in different types of business cases for monetizing this additional kind of increased cost that's occurring right now.
Okay, great. Thank you for the question. And who would like of you to start? Carol?
I think I can cover. I mean, the way our business model works is essentially we will sell the recirculated part, you know, at a price. So the way that you would get a price for a new part, we would put a price on our refurbished part, and then the only difference then with a new part is when we sell that refurbished part, we ask for the new part to be returned to us. So that's effectively a free return. So we don't pay for that coming back. That is wrapped up within the cost of what we're selling the refurbished part for. So that's how the kind of business model works, if you like. In terms of, I don't know if you meant this, but in terms of kind of monetizing the benefits, I think that's where it becomes a little bit more complex. So I think quite often when we're talking to procurement teams and on turbine operators, they have a cost of a new part and they have a cost of a refurbished part, and it's just a simple, you know, is there enough saving on refurbished for us to buy refurbished? And quite often we hear terms like, oh, it's got to be, you know, less than 70% of the cost of new for us to make it work. So that's where we could do with, I guess, a better comparison in terms of what you're actually getting for that. So it's not just buying a cheaper part. There's a lot of other aspects to consider within that as well. One of them I mentioned, you know, some of the parts where we dial in kind of improvements to failure scenarios and failure modes as well, and that becomes more tricky then to monetize that, because then you're talking about avoidance of turbine downtime and, you know, unexpected failures and things like that, and you know, that's becomes a whole life cycle analysis to try and you know, monetize the benefit of you know, purchasing one part over another part. But you know, again, we're seeing more of that happening again with, you know, with the SSE engineering teams as well. Their life cycle analysis teams are looking at that now and working with that so that we can do a better comparison of, you know, one option versus another. I don't know if that answers your question. Perhaps Alex has some thoughts on it from an operator side.
Yeah, I think it's a really good question, and definitely Carol's recognised some of those areas where it's not quite as clear cut as price being cheaper than brand new, and it's definitely something that at SSE we've spent a lot of time working through and trying to understand. We're not there yet, but we did a big exercise where we looked at our top 30 components, and then we went out to the supply chain, top 30 components for onshore wind that were routinely failing or needing refurbishment and repair. And then we went out to the supply chain to ask who could supply that. And as part of that, we're looking at things like the embodied carbon associated. We're looking at the geography in terms of the scope 2 emissions from a logistics point of view. And so we're sort of starting to artificially make selections on things beyond financial criteria. But, you know, we need to be cognizant of the fact that there are landfill taxes coming. CBAM is being introduced, which is obviously affecting the way in which materials are being brought into the EU and into Europe as a whole. And my point during my intervention around critical materials is that simply there's not enough materials for us to keep acting in the way that we are. And sooner or later, the fluctuations in commodity pricing, which, you know, I think we've all seen in the oil and gas space over the last couple of years, and that's knock-on impact on all supply chains, really demonstrates that business as usual isn't working and doesn't provide that certainty that perhaps we've been led to believe that it does. So as a developer, as an owner operator, we are constantly looking at all of those factors, all of those policies, and trying to make the right decision. I think as resources become more scarce and we become more aware of the value of resources beyond just finances, that those business cases will become clearer across the board.
Thank you very much. And I see that Amanda raised her hand.
Yes.
Hi, everyone. I just have a practicality question. So for the Coalition for Wind Industry Circularity, is this currently only based in the UK? Is there kind of a more global expansion? Obviously, with the need for wind to accelerate not only quite drastically in Europe, but also globally. Is this kind of initiative continuing to grow within like Europe and even globally?
This, I see Carol.
Yeah, I don't know. I was probably going to say the same. So I think one of the primary objectives of QUIC is to create a UK supply chain for the wind industry. But that and to focus on you know, kind of creating those businesses in the UK to support UK wind farms. But one of the primary objectives of QUIC is to do that through collaboration. So there are absolutely you know, there's a number of different members in QUIC from organizations in Europe. You know, we have turbine OEMs that are obviously feeding into QUIC as well. So it is not it's not a UK only collaboration in terms of the members, even if the focus is to try and grow that UK supply chain. So I think it would welcome you know, collaboration with partners and you know, anyone who can contribute, I think, from Europe or beyond. Hopefully you don't have a different answer, Alex. Is that that's your understanding as well? Yeah.
I agree. I think the two situations aren't mutually exclusive. You know, if all of the developers involved in QUIC standardize their procurement procedure for refurbishing components in the UK, that will benefit refurbishment service providers across the world. You know, so although we might be focused on developing that supply chain in the UK and looking at those enabling factors, that certainly doesn't prevent wider implications. Or if we're looking at policy mechanisms in the UK that they could be adopted, or you know, or even a joint statement on what we need as a wind industry to drive or increase circularity, you know, that will be applicable to other jurisdictions. And you know, QUIC is led and owned by its members, right? So if you think that there's a pressing need to expand beyond the UK and Europe, I'd encourage you to reach out to QUIC, get involved and help steer the agenda, because we very much are in this exciting space where we've got collaboration, we've got commitment, we've got agreement, but in terms of that next step of development and implementation, that's what we're struggling to sink our teeth into. So there is definitely space for others, potentially many of the people on the call who could get involved, sign up and come with us to work out how we can grow QUIC even further.
Great, thank you very much for these answers. I'm looking on the time, and we're slowly finishing, but maybe there is still one last question from the audience that you might address. I don't see any in the chat, and I don't see any hand raised. So there's a question that I have, and I was skipping it, but we have very active and engaged audience, what makes me happy. But also echoed what you just were discussing in the context of having this collaborative mindset of the added value of collaboration, of the initiative of the Coalition for Wind Industry Circularity that you established, and the importance and relevance of that, which I think is essential to progress. And this is also kind of in the spirit of RGI, what we are doing. And I was wondering, among different challenges that Carol mentioned in her slides about data, about perception, about the economy of the business, how this collaboration within the Coalition for Wind Industry Circularity, how this enabled to, and which maybe of these challenges have been addressed in the most efficient, most successful way. So short insights from both of you would be very valuable for that.
Yeah, I think I mean, I think there's an opportunity for Quick to address just about all the challenges I think I put on there. One of the kind of, or a couple of the kind of founding principles of Quick was one was to stop landfilling parts. And you know, there was that was one of the kind of requests to its members is, you know, we need to make sure that those parts are being made available for refurbishment. I don't have any stats on how much of that has been incorporated, but that would be a good question for us to ask our members next time on Quick. But that was the first point, and then the second point is the sharing of data, which you mentioned there. So sharing things like failure data and part replacement strategy, so that we can get this overall view of you know, what parts are coming out of turbines and are in demand. So you know, that top 30 list that Alex mentioned, if we had that for, you know, for a range of different turbine types, different sites, different customers, then that would allow us as a group really to narrow down on where the key requirements, where should the key areas of Quick be to focus on. So I think there's probably more to go at than has probably been achieved so far. Like I said, I think there's a governance structure reshuffle going on at the moment, and I think out of that we should get more governance and KPI monitoring around the deliverables and things. But I certainly like to see on those two. I think those two should be areas where we could pull some stats together and really see the difference that it's making.
Thank you very much, Alex. A very quick complimentary on that.
I'm usually not known for my brevity, but I'll do my best. So I think perception is something that's been addressed pretty well, and there is further to go on that. But maybe I'm in an echo chamber here. But internally, there's a recognition of the value of this. When I go along to conferences and events, I was at Aeolus, run by Wind Europe in November. You know, there's a real drive and recognition that this is the direction of travel. And I think it's easy for us to forget that in itself is a really big win. So the fact that is translating into policies around blade recycling and not landfilling blades, but also qualitative criteria and auctions is brilliant. So I think that perception battle, we're perhaps further along it than it's easy to sometimes think we are.
Great, thank you. Thank you very much for that. And with these words, I would like to say many thanks to all of you who participated in this webinar. Many thanks for Carol and Alex for providing the input and presenting the best practices and participating in this discussion. Many thanks to all the participants who were very engaged, who were interested in the topics, and we encourage you to follow up on the topic. Very soon, both the presentation and the video will be available on RGI website. We also encourage you to sign up and follow our newsletter, where we announce such events and also provide short summary afterwards. And if you have any questions to our speakers or to RGI, please feel free to contact us. We will be happy to continue the conversation. And with saying that, thank you very much for today. And I believe that we will have more chances to discuss the topic. Thank you very much and have a nice afternoon. Goodbye.
Thank
Thanks,
you.
everyone.
Thank you. Bye-bye.
Bye-bye.